Alright, in this problem here we have a square root that we want to simplify, and it is a square root because even though you don't see it, maybe I should show it to you in a different color, even though you don't see it, there is an index that's sitting right here, and it's really the number 2. So if you don't see a number that's right there, it's an understood index of 2. Alright, so we'll put here index of 2. So normally, if that's not seen, you can understand that it's a 2. Now I'm showing you that because what I'm going to do to simplify this problem is this. Switch colors here. I'm going to take this x to the 9th and I'm going to break it down. I'm going to factor it down into its factors. In other words, x to the 9th really means this. Right? X to the 9th really means x times x times x times x. That's 4. 5, 6, 7, 8, 9. So it really means 9 x's are all being multiplied together, right? This is all a bunch of multiplication here. Now, I'm kind of doing this out longhand ways. If that was x to the 19th, there's no way I would do all 19 of these x's. But I'm showing you x to the 9th because it's not that difficult to do. Alright, what am I doing with it x to the 9th? Well, because the index is a 2, and even though, again, if you don't see it, it's an understood 2, what I'm going to do is I'm going to look for identical pairs. And so here's a pair of x's. Here's another pair of x's. So I'm just going to circle a bunch of pairs of x's. And do you see that this last one over here doesn't have a pair? There's no identical pair. And what I often say in class is that each of these pairs now, quote-unquote, gets married. And maybe you've heard the priest or the minister, whoever up front conducting the wedding, says that, okay, now the 2 shall become 1. So they come out of the radical sign as a single x. Right? Same thing with this one here. It comes out of the radical as a single x. Comes out as a single x. And this last one here comes out as a single x. So I hope you see that now, look, 4 sets of x's came out, right? 1, 2, 3, 4 sets of x's came out. So I have out front an x to the 4th. But because this x didn't have a partner, nobody to marry up here or buddy up with, it still remains inside the radical. So there, you just simplified the square root of x to the 9th. You can write that as x to the 4th radical x. Alright, let me do one more for you. Let me do one more. What if the original problem looked like this? What if instead of a square root, I put a 3 as the index right there, and it's a cube root? Well, the process is exactly the same, at least at the very beginning. Right? So I got a big old square root, and I've got 9 x's sitting inside there. But this time, because the index, let's see, it's 5, 6, 7, 8. Right? Is that 8? I've got 8 of them, and now I've got 9 of them. Okay, so because the index now is a 3, right, this index here is a 3 instead of an understood 2. Now this time, instead of looking for identical pairs, I'm looking for identical triplets. Okay, and here's where my marriage analogy kind of breaks down, because 3 people don't get married. That just doesn't make sense. So, anyways, I'm looking for identical triplets, and these triplets are coming out, guys, still as a single entity. As a single entity. Okay? So I hope it's easy to see that I have 3 x's coming out, and nothing is left inside this radical. This, by the way, is a cube root. Almost forgot to put that there, didn't I? But still, look, nothing is left inside the radical. All of these x's came out because I could split them up into groups of 3's, and so I hope it's easy to see. Look, I have x times x times x out front. I have a final answer of x to the 3rd, and that's it. Nothing is left inside the radical, so I'm not even going to write the radical sign. No cube root or anything like that after it. That's my final answer there. Again, it was the exact same problem, but a square root here. I had 4 groups of x's come out, so that's x to the 4th, and 1 lonely x left inside. Again, I don't really need to write the 2 here, because that's understood as the index. Hope that helps.